Okay, so let's talk about another kind of example right here. And this time, we want to talk about a cup of coffee. Being in the morning, I've just had my cup of coffee. So let's see what happens. A cup of coffee is heated to 180 degrees Fahrenheit. And then we place it in a room that maintains a constant temperature of 65 degrees. Well, what happens to the temperature is due to something called Newton's law of cooling, and we're kind of getting the end result of all of this. When you go into a calculus class, you'll see later on that this is actually a pretty good model for what's happening. It says the temperature of the coffee after t minutes is given by the function t, capital T of t, equals, in this particular case, 65, which is the ambient temperature in the room, plus 115. By the way, 115 happens to be the difference between 180 and 65, times e to the negative 0.042t, where t is time in minutes. And so the question is asking us to find the temperature to the nearest degree of the coffee after 10 minutes that it's placed in the room. So what does that mean? Well, of course, just like our last model, we're just going to substitute in, and we want to find out what happens at t equals 10 minutes. So let's make that substitution into our function. The temperature, capital T, of this cup of coffee at that 10-minute mark, according to this model, should be equal to 65 plus 115 times e to the negative 0.042 times 10. So what happens right here? Okay, as we said before, 65 plus 115 times e to the negative. It'll be shifting that decimal to the right by 0.42, negative 0.42. So let's get out our calculator and work this one out here. We say we want to take 0.42, the negative of that value, and we're going to raise it to exponentiate e to the negative 0.042, so e to the x right here. We're going to multiply that value times 115 right here. And we're going to add that temperature to our 65 degrees. And what does that give us? 140.56 right here. 140 approximately 0.56. Now, did we answer the question? Well, not quite yet. It says find the temperature to the nearest degree of the coffee after 10 minutes. So we're going to say that at 10 minutes, we would say approximately 141 degrees Fahrenheit. Now, does it keep on decreasing at a constant temperature? No. We could see what's going to happen here, and we can keep on going. Eventually, like our other model, what would happen over time is that that cup of coffee's temperature will approach the room temperature of 65 degrees Fahrenheit. So eventually, after some minutes, later on, we'll find a way to solve this. We need to go a couple of sections ahead here to do that, but we'll find out, well, how many minutes would it take for this temperature to reach a certain value, right? So that would be our model right here. But this is a good beginning right here, an application using Newton's law of cooling. Okay, good luck on your homework.